It is my pleasure to have you here today on the Drowsy Science Channel. Our home planet's incredible beauties will be our focus tonight. On this planet, life has evolved in incredible ways, and we're going to learn about a few of them. In every shape and form, life is all around us. It clings to rocks in the harshest deserts, wanders invisibly in the air we breathe, and shines gently in the deep ocean. Some animals have persisted through seemingly inhospitable environments for countless generations, while others have evolved to live in extremely harsh environments. Every one of them is a little miracle in its own right, contributing to the larger whole that binds us all together. Feel free to subscribe, like, or comment with your favorite fact if you enjoyed these light adventures. A lot of people use it to get around here too. Restless spirits rescued one by one. Rest is all that's required of you at the moment. As the tales of life play out, take deep breaths, pay close attention, and let your mind relax. This is where we will start. Ocean vents may have been the first places life on Earth emerged. Warm waters under a gentle sun are common images that come to mind when we consider the beginnings of life. The story may have started in the deepest, darkest places, hydrothermal vents, according to modern scientific belief. These peculiar chimney-shaped formations release scorching water that is mineral-rich and originates from deep within the Earth. Despite how hostile it seems, the chemistry is really out of this world. The minerals serve as catalysts, forming microscopic cavities that may have housed the complex formations of once simple molecules. Scientists have long speculated that these mineral enclaves served as a safe haven for newborn life, a place where they could develop in relative peace and quiet amid the mayhem that surrounded early Earth. These vents are nevertheless home to many species that get their energy from the Earth's chemistry rather than sunlight. The thought that our common history might have begun with cold, pressure, and darkness, rather than light and warmth, is disheartening. Frozen solidness isn't fatal for certain animals. Envision yourself completely immobilized, only to thaw out and resume your normal activities as if nothing had transpired. Some animals don't see this as fantasy. Staying alive is the goal. The wood frog is one of few North American frogs that can undergo near-total body freezing throughout the winter. Their hearts cease to beat. They stop bleeding. They remain alive, nevertheless. To prevent their fragile cells from bursting, their bodies contain certain molecules like glucose, which function as natural antifreeze. A lot of little invertebrates and frogs have figured out ways to survive in the deep freeze that would kill most other kinds of life. When spring comes around and the ice melts, they hop away unscathed. These adaptations serve as a reminder that life is resilient and creative, even in seemingly hopeless situations. It's as though the capacity to halt and restart the beat of life is scripted into Earth's script. Some creatures don't even need sunshine to survive. The sun is commonly believed to be the most important factor in maintaining life on Earth. Its light nourishes plants. Once plants are consumed by animals, the cycle is perpetuated. On the other hand, complete ecosystems flourish in total darkness at the bottom of the ocean, where light can never penetrate. There are a lot of blind crabs, gigantic tube worms, and ghost fish around hydrothermal vents. Chemosynthetic energy production allows these microbes to subsist not on sunlight, but on substances such as hydrogen sulfide that escape from the vents. These microbes are the ground zero of an ecosystem that thrives in complete darkness. Similar adaptations have been developed by other creatures in underground caverns that have never seen the sun. They learn to navigate by increasing their sensitivity to touch and smell, and by contracting or eliminating their eyesight. Despite popular belief, light is not essential to life. Darkness allows it to construct its own universes. Over 500 million years ago, jellyfish began drifting through the seas of Earth. The age of jellyfish predates that of dinosaurs, trees, and nearly all forms of life known to us today. For over 500 million years, they have quietly circulated throughout the world's seas, surviving the destruction of innumerable other species. Everything about their bodies is out of this world. Inert bags of tissue, composed primarily of water and devoid of any organs whatsoever. Still, their design has remained largely unchanged throughout the ages because of how effective it is. As they float on the wind, they can be seen from space in massive blooms, or they can be illuminated by a mystical light. Even though they don't look like much, jellyfish are masters of survival. They can repair themselves and even live in environments where other fish perish. Gazing at a jellyfish as it gently swims through the water is like peering into the depths of time, beholding the tenacity of a blueprint that has served its purpose for 500 million years and is still going strong. For energy, some microorganisms may consume rocks. What most of us picture as food is either sunlight, animals, or plants. However, there are bacteria that have an entirely different menu. They get their nutrition from rock and mineral sources. The ability to remove electrons from materials such as iron, sulfur, or even uranium has been discovered by certain creatures known as lithotrophs. Drawing energy from this chemical process, complete microbial populations subsist on this peculiar diet in the darkest recesses of the Earth's surface, far from any source of light or organic matter. They may be a representation of extraterrestrial life, according to some scientists. A simple, resilient being that can get its food from stone. These microscopic organisms have the incredible ability to transform the minerals they come into contact with by changing the surrounding chemical composition. They may have played a role in shaping Earth's environment over billions of years. Imagine these unseen miners as you consider the resiliency of life, patiently consuming rocks in the dark and flourishing when nearly nothing else could. More than 10,000 years have passed since the first known living thing. In comparison to our own lifetimes, which are measured in decades, the ages of the oldest animals on Earth appear nearly incomprehensible. Submerged for over 1,000 years, clonal colonies of seagrass, or Posidonia oceanica, have persisted in the Arctic. Some land-dwelling clonal trees, such as the Utah quaking aspen pando, have genetically identical stems and can cover whole forests. Every one of them is connected through an ancient root system. These creatures have survived through many ice ages, far longer than any other species on Earth. Longevity in nature is often about continuity rather than the individual, as these examples show. A kind of life that can persist for a long time because it can regenerate itself. Being in the company of such long-extinct creatures makes the passage of time seem infinite, as if the Earth's pulse is measured not in years, but in the size of its woods and seas. Over millennia, certain trees have developed the ability to replicate themselves. Although trees often appear silent and alone, they actually possess a hidden ability, the capacity to replicate themselves. Roots can emerge from plant stems as soon as they make contact with soil. New trunks emerge as time goes on. Willows and poplars are two examples of plants that spread in this manner, resulting in massive stands of genetically similar trees. Poe, the shaky behemoth from Utah, is the most well-known of these. 40,000 individual stems that make up a forest that is believed to be thousands of years old. A tree's ability to reproduce by sending up new shoots when old ones die allows it to survive indefinitely, in contrast to most animals. A forest can be both dead and alive, old and young. It serves as a gentle reminder that life can outlive its apparent expiration date by quietly persisting over generations. Over in Oregon, a fungus occupies about 10 square kilometers. The Armillaria ostoii fungus, one of the biggest known living organisms, is found in Oregon's Blue Mountains. It seems like a few mushrooms sticking out of the woodland floor at first sight. However, mycelium, a web of interwoven filaments, extends across roughly 10 square kilometers of earth below. This enormous creature has been around for thousands of years and is thought to weigh hundreds of tons. Despite its stealthy growth, it outreaches even the biggest creatures. Invading tree roots, its filaments gradually break down wood, reusing the forest in the process. As you make your way through the forest, you could get the impression that you're walking amongst several small trees and mushrooms. However, what you're actually walking on is the living skin of a much larger organism, a hidden behemoth that subtly rules its territory, awe-inspiring and terrifying all at once, symbolic of the fact that hidden giants abound on this planet. Your body contains more microorganisms than human cells. If you consider yourself to be an isolated entity, science provides a sobering reality check. A living ecosystem, you are. There are at least 10 times as many microbes as human cells in your body. Your skin, mouth, intestines, and tissues are all habitats for various microbes, including viruses, fungi, archaea, and bacteria. The term for all of these microbes is the microbiome. Plus, they affect our energy levels, immune systems, moods, and digestion. A large number of them are crucial. We would perish if they weren't there. Still, some live side by side, doing no damage and providing assistance. They come together to build a bustling metropolis inside of you, one that is always evolving in response to your food, surroundings, and life experience. Realizing that you are more microbe than human makes it obvious that you are never truly alone. Every one of us is a network, a delicate dance of many beings sharing a single vessel, even within our own bodies. Space is habitable for tardigrades. The little snout-topped, eight-legged pillows that are tardigrades are commonly known as water bears. Their famed toughness belies their diminutive size, less than a millimeter long. They enter a condition known as cryptobiosis and dry out nearly entirely when circumstances become harsh, such as when water runs out, temperatures fall, or radiation levels soar. When in this condition, they are able to withstand conditions that would be fatal to most creatures. Even after being exposed to radiation, freezing, boiling, and the emptiness of space, they manage to survive. They can be brought back to life after being dormant for a long time by just adding water. A combination of unique carbohydrates and proteins stabilizes their cells, preventing harm to their DNA and membranes. This is their secret weapon. Their very existence demonstrates that even despite seemingly insurmountable odds, life can persist. The existence of tardigrades and other similarly tough organisms suggests that other, more distant worlds may harbor similar capabilities. Changing sex is a lifelong process for certain fish. Underwater, gender is not always a fixed concept. Changing their sex is a remarkable trait that many fish possess. As an example, in clownfish populations, The largest and most powerful member transforms into a female while the rest stay male. In her absence, the next biggest guy will metamorphose into a female and assume her role. Depending on the needs of the group, males in races and groupers may switch roles with females or vice versa. Adaptations in behavior, hormone levels, and even the structure of reproductive systems are all part of these modifications. It serves as a gentle reminder that the seemingly inflexible categories might actually be quite malleable. Being adaptable is often crucial for staying alive in the ocean. By rewriting its own laws to guarantee the continuation of its lineage, this fish shows us how adaptive life can be. An axolotl's brain may regenerate. Among amphibians, the axolotl stands out. It is also known as the Mexican walking fish. It appears otherworldly just from looking at it, what with its fluffy gills, eternal grin, and young looks. That being said, it is accurate. Regeneration is where marvel happens. When injured, humans leave scars. Axolotls, on the other hand, may regenerate lost limbs, spinal cords, hearts, and even brain tissue. When they sustain an injury, their body's specialized cells, which resemble stem cells, transform into a more malleable form and meticulously restore the damaged areas. Axolotls have a remarkable ability to regenerate, and scientists are studying them closely in the hopes of understanding it. Just think of how amazing it would be if people had the ability to regenerate organs or fix spinal injuries just like these tiny salamanders. Regeneration is more of a way of life for the axolotl than a miracle, a restorative cycle that keeps it looking fresh and strong in the oceans it inhabits. It takes months for some frogs to release their breath. There are frogs that, in the dead of winter, pull off an almost unbelievable accomplishment. They go into a suspended animation when they halt all respiration and hide in the dirt or behind the leaves. For instance, the marsh frog can stay submerged for months on end, getting all the oxygen it needs from its skin. In order to wait for spring to arrive, some species put their bodies on hold and reduce their metabolism to a crawl, allowing them to exist on nearly no oxygen. They manage to stay alive in environments that would kill most other animals by maintaining a fine equilibrium. When the weather warms up again, they snap out of their slumber and start croaking like nothing ever happened. Being able to endure hard seasons in silence is a testament to the patience of nature. The key to surviving isn't always moving, but rather being calm and collected until help arrives. Cavitation bubbles can be produced by some shrimp species at temperatures greater than those of the sun on Earth. The tiny pistol shrimp, which has a claw that acts like a weapon straight out of science fiction, is one of the most remarkable creatures on Earth. It produces a low-pressure bubble when it snaps its claw shut, which is caused by a rapid jet of water. A shock wave is produced when the bubble bursts, which incapacitates or kills any close prey. For that split second, a flash of light visible only with specialized gear and temperatures higher than the sun's surface is produced by the burst bubble. Not bad for an organism that is only a few centimeters in length. As hundreds of thousands of pistol shrimp snap their claws in time, the sound they make can resemble the crackling of underwater fires. That such a little object could concentrate such tremendous energy is nearly unbelievable. Evidence that nature conceals the potential to release forces comparable to those of the stars even in the smallest bodies. The magnetic field of Earth helps some birds find their way around. Incredibly precise navigation across thousands of kilometers over oceans and countries begs the question: how can a bird know its destination? Many animals, according to scientific research, have an innate ability to detect and navigate through Earth's magnetic field. Magnetoception is a sense that is believed to be mediated by either light-sensitive proteins in the eyes or by minute magnetic particles embedded in their tissues. For some avian species, magnetic fields may appear as subtle patterns superimposed on their environment. They navigate wide, featureless skies devoid of markers by use of this secret sense. As a result, migratory birds like Arctic terns and pigeons are able to navigate to their nests even while they're in new areas. The Earth's magnetism is imperceptible and unseen by humans. For these avian creatures, though, it's like a subtle map etched into the air itself, leading them aimlessly over the world. The migration of monarch butterflies can cover thousands of kilometers. One of the most incredible migrations in the animal realm is embarked upon each fall by millions of monarch butterflies. They travel from North America to the mountainous central Mexican forests on delicate, papery wings, an adventure spanning thousands of kilometers. Considering that not a single butterfly makes it all the way around, this achievement is very remarkable. Along the road, generations are born, everyone carrying on the path laid down by those who came before them. As they make their way north in the spring, they will have passed the migratory torch on to the next generation, the great-great-grandchildren of the butterflies that set out months before. They return to the same woods and even the same trees year after year, guided only by instincts that we can only speculate about. As the trees burst with a flurry of orange and black wings, it's as if you're witnessing a piece of living poetry. Nimble creatures following the invisible paths etched into their very essence. Tricardia and blue blood are characteristics of octopuses. The octopus's unique blood and circulation make it one of the most clever and bizarre organisms on Earth. Octopuses have 3 hearts, unlike humans who only have 1. 2 circulate blood via their gills, and a third carries it throughout the body. Their blood is copper-based, not iron-based. Hence, it's a pale, ice blue color instead of the red color ours is. This change makes it possible for them to stay alive in water that is chilly and low in oxygen. The octopus is nevertheless awe-inspiring in other ways. They have freakishly good problem-solving skills, can alter their skin tone and hue on the fly, and can fit into incredibly tight areas. Octopuses are like alien intelligence. They're sentient beings whose bodies and minds have developed in entirely different ways from our own, proving once again that there is no one set design for how life should unfold. Crows have eyes that can detect human faces. The thinking and memory capacities of crows are comparable to those of certain primates, making them one of the most intelligent bird species. Their remarkable talent for face recognition is one of their most impressive abilities. Crows have shown memory and behavior changes in response to persons who treated them badly in studies, going so far as to warn other crows about those people. Their memories of those faces persist even after all these years. However, resentment isn't the sole factor. They are able to identify nice people and will occasionally leave trinkets, such as glass fragments or bright pebbles, as a thank you for food. They have a level of social intelligence that is very similar to ours in their capacity to recognize and recall individual faces. As you watch a crow turn its head to look at you, you can't help but wonder who is doing the actual spying. Behind those dark eyes is a mind that recalls memories, passes judgment, and maybe even tells tales to its young. When dolphins interact, they use specific names. Living in close-knit communities characterized by play, cooperation, and communication, dolphins inhabit the shimmering underwater world. Their ability to distinguish one another through the use of unique whistles is one of their most striking characteristics. The dolphin's name-giving mechanism. The distinctive whistling that develops in each calf is something that it has with it forever. Dolphins communicate with one another through this sound, and some individuals can even identify their own name when it is made by another dolphin. This skill is unusual among animals and may indicate a level of social awareness and self-consciousness that is unique to humans. It sounds like a marine version of roll call, but dolphins have been heard calling the names of friends who have been removed from them. Envisioning a school of dolphins gracefully swimming through the ocean, while simultaneously whistling out names, gives us a glimpse of the advanced civilization that lives beneath the waves, whose languages we are just now starting to decipher. Storms can be detected by elephants from hundreds of kilometers away. Both physically and emotionally, elephants are enormous. They are able to feel impending storms from incredible distances, sometimes hundreds of kilometers away, thanks to their feet's ability to detect faint vibrations and ears that function like excellent receivers. Infrasonic sounds, which are rumblings that are much below the human hearing range and are caused by thunder or changing weather systems, are something that researchers are hoping to pick up. They can then start their lengthy travels in search of water and refuge. Similarly, elephants have been seen exchanging messages across huge distances, utilizing these low-frequency cries. They are remarkably attuned to the subtle vibrations of the earth and sky, given their enormous size. When you're in close proximity to an elephant, you're in the presence of a sentient entity that knows the earth like no one else and can sense its vibrations in ways we can't even begin to fathom. The whale's melodies evolve across the years. Under the water's surface, where the sun sets into an infinite blue, humpback whales make their melodic songs heard. The sea carries their lengthy, eerie symphonies, laments and groans for hundreds of kilometers. As the whale leisurely swims or glides along, its songs can reverberate in cycles that can endure for hours. Not only is the beauty of these tunes remarkable, but so is the fact that they evolve. Whale songs undergo a collective transformation over the course of months or even years, with certain phrases added and others removed, as if the whole whale population had come to a consensus to rework the tune. As a result of these shifts, the music of one area begins to permeate another, much like cultural waves across the sea. From time to time, whole groups will suddenly start singing a completely new song. No one knows for sure why whales do this, including scientists. Does it involve courting, conversation, or just artistic pursuits? For whatever reason, their voices transform the sea into an ever-changing, ever-living symphony. Bats can find their way around using polarized light. Twilight reveals patterns in the sky that were previously unseen as the sun dipped below the horizon. As light travels through the air, it forms polarized bands that are visible to some, but not to others. Amazing night explorers like bats may pick up on these subtle signals. On long treks, they utilize them to stay oriented, using the sky as a silent compass marked by changing light. Bats use echolocation in conjunction with this concealed map to navigate perfectly over great distances, not only darting through trees. Think of the waning light in the sky as a network of gentle arrows leading you home, rather than a faded rainbow of colors. Bats comprehend additional dimensions of information that humans cannot. Their journey serves as a poignant reminder that the planet is teeming with hidden messages, and that the ways in which nature guides us may be both nuanced and profound. Even without a brain, slime molds can solve mazes. Slime molds are an entirely new kind of organism, distinct from all other known animals, fungi and plants. They are enormous single cells that move gently over surfaces, searching for food with their delicate tendrils. Despite lacking neurons and brains, they exhibit an intelligence that questions our understanding of thought. Slime molds were placed in labyrinths with food supplies at 2 exits in order to conduct studies in the lab. The organism slowly made its way into the halls, avoiding obstacles, strengthening its shortest route, and, as if solving a puzzle, following the most efficient route. They act as if they recall prior occurrences and can even predict when they will occur again. Incredible for a creature devoid of a central nervous system. The fact that slime molds can form suggests that the ability to solve problems may arise from the coordinated actions of cells rather than just the brain. They represent the new knowledge. Being intelligent is more of a function of being alive than a shape itself. Underneath the earth, you'll find ant farms. Ants were engaged in agricultural activities even before humans cleared land for planting and tending crops. For example, ants that cut leaves, march in seemingly continuous processions, plucking leaves from plants and returning them to their underground abodes. Their diet does not consist solely of leaves, though. Instead, they meticulously mulch the plants and feed them to fungus that grow in the nest's damp chambers. The ant's principal source of nutrition is this fungus. Fungi and ants have co-evolved into mutually dependent species over millions of years. Fungi and ants are mutually dependent on one another for survival. As if that weren't incredible enough, the ants use the symbiotic bacteria already living on their bodies to protect their crops from pests by secreting medications. Ants manage to pull off what humans have only just begun to do in the past 10,000 years. Underneath our feet, in the dirt, there is an old farm that we hardly pay attention to. Colonies of leafcutter ants can reach urban sprawl proportions. There are millions of leafcutter ant colonies, each with its own intricate network of tunnels that spans dozens of meters. Colonies are more than just a place to lay eggs. They are bustling metropolises where workers wave verdant flags as they travel the highways back and forth. The subterranean building is partitioned into sections for specific purposes, such as large nurseries, the queen's vaults, and enormous holes for mushroom cultivation. As a result of her prolific egg-laying, the queen may extend her reign for up to 20 years. Using pheromones, scent trails that function like public announcements, communication flows, directing labor with extraordinary precision. These colonies seem a lot like human cities when mapped out by scientists. They even have systems in place to divide up resources, regulate waste, and divide up labor. Here, though, architects rely solely on gut feelings to direct their work. This is a really disheartening discovery. Subterranean organisms no larger than a human fingernail build complex societies on par with our own. Mounds constructed by termites serve as a natural air conditioner. In the African and Australian hop savannas, termite mounds, which may reach heights of over 6 meters, resemble earthen churches. Termites, numbering in the millions, are inside, diligently caring for their colony and cultivating fungus to feed themselves. The most astounding thing is that these mounds manage their interior climate with pinpoint accuracy, even though it's freezing at night and scorching during the day. Remarkably, the inside remains unchanged. The building's porous walls, chimneys, and vents make it function similarly to a lung, regulating airflow and temperature. Termites are always adapting the mound to new circumstances by fixing holes, expanding or contracting tunnels, or both. Their innovative designs have piqued the interest of architects who are looking for environmentally friendly ways to cool buildings. Stand next to one of these buildings in your mind. A living, breathing skyscraper crafted from grain-by-grain clay, housing a civilization that places greater faith in natural architecture than in most human-designed structures. The deep ocean is illuminated by bioluminescent animals nowadays. Even in the darkest, most remote parts of the ocean, there is light, light that gives life to life itself. Numerous creatures inhabit this area, and their bioluminescence emits light in a spectrum of blue, green, and occasionally red shades. Little plankton glisten like stars in the night sky, and fish follow shiny lures to catch food. Some jellyfish can transform into living fireworks by pulsating with neon patterns, which fool predators. Down here, light serves as a means of locomotion, communication, hunting, and hiding. There are animals that glow all the time, and others that burst into light like explosions in the night. Glistening waters have always been a source of both awe and terror for mariners. But for the native fauna, this light represents communication, a means of subsistence, and even creativity. The darkest parts of the ocean really have the most brilliant light, because that's where light of a different kind was born, in the absence of sunshine. Over whole woodlands, fireflies synchronize their flashes. During rainy seasons in the Great Smoky Mountains and Southeast Asia, fireflies turn the night sky into a dazzling light show. Their bursts of light appear haphazard at first. Then, seemingly out of nowhere, whole communities start pulsating in time with one another. A forest's pulse echoed by thousands of little lanterns flashing in time. As the pattern spreads over the trees, the synchronization occurs organically as fireflies adapt to their neighbors. Researchers think this synchronization makes them more attractive to potential partners. Adding a human touch, though, makes everything seem miraculous. Envision yourself strolling through the forest while the air is filled with the rhythmic rise and fall of golden light, as if the trees were breathing. At precisely precise times, microbes the size of rice grains produce displays that are comparable in scale to the most spectacular human fireworks displays. As part of their ephemeral dance, they perform it night after night, not just once a year. Certain species of squid have the ability to become undetectable. The squid is a master of persuasion. Their skin is filled with cells that have the ability to change color, reflect light, or even scatter light like glass. In a coordinated effort, squids' chromatophores, iridophores, and leucophores allow them to rapidly alter their patterning to seem like anything from stripes to ripples to camouflage that blends in flawlessly with either open water or sand. But there are some creatures that can go much farther and make themselves almost invisible. They fade into the glistening water around them by carefully dispersing light. Their silhouettes vanished. Some transform into see-through creatures, their internal organs barely visible as they lose all trace of themselves in the water. Being undetectable provides an unparalleled layer of protection when venturing out into open water. Squid use it as a hunting technique as well, appearing to their victims as specters as they sneak up on them. These peculiar sentient cephalopods of the ocean have perfected the science fiction concept of invisibility. Not all sharks are visible in dim light. Even though sharks have been around for a long time, some of them even serve as marine lamp-bearers. One example is the bioluminescent shimmer that lantern sharks exhibit. This shimmer elongates their underbelly and gives them a gentle green or blue light. Camouflaged by this glow, they mix in with the surface's weak light, keeping themselves inconspicuous to predators below. In the dark, other sharks that shine indicate possible mates or competitors. Photorays, which are light-producing organs dispersed across their bodies like a constellation of living stars, are responsible for the glow. These sharks float like swimming stars in the ocean's twilight zone. The ocean takes on a haunting allure when one envisions a predator gleaming gently in the depths. Even hunters carry lanterns, turning survival into a drama of light rather than a desolate wasteland. The average lifespan of a Greenland shark is about 400 years. One of the most enigmatic creatures on the planet, the Greenland shark, lives in the frigid North Atlantic waters. Gliding slowly over the depths, these gigantic beings can have amazing lifespans, despite being blinded by parasitic worms that stick to their eyes. They are the longest-lived vertebrates known, with specimens reaching back more than 400 years according to radiocarbon dating of eye tissues. Prior to the invention of the telescope, the rise and fall of empires, and the writing of Shakespeare's plays, some people lived. A mature Greenland shark could be more than a century old, and its growth rate is often less than 1 centimeter each year. They appear to be immune to the effects of time due to their slow movement and frigid environment. Time moves differently for other creatures that share our world with us. Just try to picture a creature traveling silently through dark seas for eons. There are fish that can last weeks without breathing air. Without oxygen, most species would die very quickly. Some fish, however, exhibit extraordinary resilience in water bodies where ice caps the surface during winter and oxygen levels drop. By putting their metabolism into an odd gear, goldfish and their wild relative, the crucian carp, may survive for weeks without oxygen. Instead of the harmful lactic acid that humans produce when they don't have enough air, they make ethanol, which is like alcohol, and release it into the water surrounding them. They are able to endure the long, cold winters in relative safety because of this biochemical trick, and they only emerge when thaw comes back. This is one of nature's most incredible metabolic hacks. It's not easy, but it's survival. In contrast to us, these fish can remain motionless for hours at a time, demonstrating that the laws of nature can change in response to external pressures. For years, lungfish have been known to hibernate in dirt. Many fish die as rivers dry out to cracked clay due to a severe drought. However, the lungfish are not considered. Being a fossil with gills and lungs, this ancient survivor has mastered the art of waiting. Lungfish hide in the dirt as the water recedes, secreting a sticky cocoon that eventually hardens around their bodies. On the inside, it reduces its metabolic rate to a whisper and takes calm, regulated breaths via its lungs. This can last for a long time, months or possibly years, until the rivers fill up with rain. Then, as if nothing had transpired, it wriggles free with incredible patience. Lungfish are able to survive temperatures that would be lethal to most vertebrates because of a state of suspended animation known as estivation. A lesson in perseverance is etched into their very bones. Rather than fighting the drought, they plan to sleep through it, believing that water will eventually come. Spawning can require some eels to swim thousands of kilometers. Eel life was shrouded in obscurity for ages. Since there was no proof of reproduction, Aristotle once pondered their origin. It has recently come to light that eels perform one of the world's most extraordinary migrations. Both American and European eels spend the vast majority of their lives in aquatic environments, where they can live for decades. When mating season rolls around, they set out on a remarkable voyage of thousands of kilometers to the Sargasso Sea, an area of the Atlantic Ocean teeming with floating seaweed. They lay their eggs and then die out in the open sea. Their baby eels, which are tiny, translucent larvae that resemble willow leaves, return to rivers their parents never saw as they float on ocean currents. This cycle remains a mystery to this day because of how unlikely and enigmatic it is. The eel's life cycle is still a mystery to this day. Parrotfish lay their eggs in protective mucus sacs. At dusk, parrotfish burrow beneath coral reefs to get ready for the night. However, rather than stowing away in a crack, they encase themselves in a see-through bubble made of secreted mucus. To evade predators like moray eels, they sleep in a slimy sac that covers their scent. Additionally, it has the potential to protect against parasites. Strange and enchanting, like witnessing a being cloaked in a spectral cloak, is watching a parrotfish swim inside its own glistening bubble. In the morning, the fish escapes and begins its day of constructing tropical beaches by crushing coral with its beak-like jaws. This process is repeated nightly, a mucus-based bed, a flimsy defense against the night's perils. Every aspect of this clever routine serves as a constant reminder that even the act of sleeping in nature is never easy, but rather a survival mechanism. Maws are the reproductive organs of seahorses. In the aquatic habitat of seahorses, the conventional order of things is turned upside down. Male seahorses don't do what most males of their species do when they compete for the opportunity to fertilize eggs. Babies are carried by them. The female lays her eggs in a specific pouch on the male's body after a series of delicate displays and dances known as courting. He tends to their needs for fertilizer, oxygen, and nutrition while they grow in that spot. After a few weeks, he gives birth and releases a clutch of tiny seahorses into the water. This unusual setup allows the ladies to focus on egg production while the males tend to the young. It is a strange and emotionally wrenching sight to see a mother seahorse writhe as hundreds of baby horses burst into the water during delivery. It demonstrates that biological gender roles are malleable and that parenting may take many shapes and sizes. Our expectations are turned upside down by the seahorse. Insects have the ability to float on water. The long, slender legs of the delicate water strider insect allow it to skate across streams and ponds with the ease of a skateboarder. Physics holds the key to their secret. Leg hairs are so little that they deflect water and trap air, making it impossible for them to breach the surface tension. Like an invisible trampoline, they use each step to press against the rippled water beneath them. Strider colonies can congregate and glide over a mirror stage in perfect harmony. Surface waters provide food and refuge from underwater predators. Thus, to these creatures, the water is more like a second home than a barrier. These insects are marvels to us because they can walk on water. Over millions of years, it just impacts everyday life. Observing their graceful movement over placid ponds is like getting a sneak peek at a different set of regulations. One in which the boundary between the two media is a game. Radiation isn't going to kill water bears. Among the most indestructible forms of life we know of are tardigrades, which are little, fat creatures that are commonly called water bears. The radiation levels they must tolerate are thousands of times greater than the amount that would kill a human being, on top of having to endure the vacuum of space. They enter a state of near-death known as cryptobiosis and produce special proteins that protect their DNA from harm. During this phase, their bodies get parched. They have a nearly non-existent metabolic rate, and their cells are protected from damage. Reviving them with only a drop of water is possible even after years have passed. Their resiliency has scientists wondering whether it could have uses in radiation protection, long-duration spaceflight, or perhaps human health. The invisibility of water bears serves as a reminder that stamina, not stature, is the true measure of strength. Resilience enough to face insurmountable odds and emerge victorious. Algae can live within rocks. Life has discovered a method to hide in some of the world's most hostile deserts, where the surface is unbearably hot and dry due to the winds that blow across the landscape. For protection from the environment, some types of algae live in the cracks and crevices of rocks, where they burrow into the mineral layers that are see-through. These creatures have evolved to live in environments with very little light and very little moisture, which they obtain through small fissures in rock. Being alive is a risky business. Even yet, it enables them to persist in environments where essentially no other life forms do. Their severe conditions serve as a model for Mars, and scientists have found them in the Atacama Desert and Antarctica's dry valleys. That abundance is not necessary for life is whispered by these hidden algae. All it needs is a chance. Conceiving of a life within stone challenges our assumptions about the kinds of environments that could support life and encourages us to think about other planets that might be habitable. Algae and fungi form lichens, which are partnerships. Simple crust or moss patches attached to rocks or trees are what lichens appear to be at first sight. On the other hand, they are not isolated creatures. In these complex relationships, cyanobacteria and fungus work hand in hand. While algae contribute by absorbing energy from sunlight through photosynthesis, the fungus offers shelter, structure, and access to minerals. Their combined value exceeds that of their individual components. As they spread across surfaces, lichens gradually erode ice, expose stone, and even rooftops, making room for new forms of life. They are able to survive in conditions that would be fatal to other plants, such as frigid tundra and hot deserts. Legend has it that certain lichens can live far into their thousands. We learn about collaboration from their calm persistence, coming together as two drastically different kinds of living. The importance of cooperation rather than rivalry in ensuring one's survival has been demonstrated. A timeless lesson passed down through the generations. The planet itself. Some microbes use metal as an oxygen source rather than air. In order to breathe, the vast majority of Earth's living things need oxygen, the chemical molecule that permits the transfer of energy by taking in electrons. A few types of bacteria, however, can survive in completely oxygen-depleted settings. Metals are utilized instead in subterranean aquifers, caves, or deep mud. As part of their metabolic process, bacteria can exhale iron, manganese, or even uranium to replace oxygen. Subtly altering their habitats, these creatures coat rocks with a rusty patina or change the chemical state of metals. Their skill suggests a time when oxygen was rare and alternative elements propelled the chemistry of life. Additionally, it raises the prospect of life on extraterrestrial planets devoid of oxygen. Thinking about organisms that take in oxygen from metal demonstrates the adaptability and resourcefulness of the living, which can turn seemingly dead matter into a source of energy for further growth. Microbes exist that can break down plastic. The ubiquitous plastic has become one of humanity's most defining features. It refuses to decompose for ages and clogs up seas and soils. Life has yet managed to get a hold of even this man-made substance. Microbes that can decompose specific types of plastics and use them as fuel have been found in recent years, according to scientists. Polyethylene terephthalate, a substance used in bottles and packaging, may be broken down by enzymes produced by one bacterium, Idonella sachensis. In vitro studies have demonstrated that fungi can also break down polymers. Even though they are clumsy and unrefined, these skills show how adaptable life is. Organisms are adapting to use a material that has never been present in nature before, and this is happening in the span of a few decades. It is a stark illustration of the magnitude of human influence, yet it also proves that life is determined to adapt to any situation it faces. Subterranean fungal networks allow trees to communicate. A secret web of fungus threads weaves through the forest bottom, connecting tree roots into extensive networks. Trees transfer carbohydrates, nitrogen and phosphorus to one another via their root systems. Even in times of drought or pest infestation, they may send out chemical signals to alert people. Through these networks, larger, older trees, sometimes referred to as mother trees, provide nourishment to smaller seedlings, increasing the likelihood that the next generation will survive. This extensive network is known as the wood wide web among scientists, connecting the woodland through a subtle pathway of communication. Below ground, trees are constantly exchanging information, more like a community than individuals, even though they seem quiet and isolated from the ground above. Realizing this, when you go through a forest, changes your perspective. There is a dialogue between roots and fungus that has been going on for millions of years, and every trunk is like a tower connected by hidden threads. Chemical alerts can be released by plants to their neighbors. Plants are not passive, despite being rooted and motionless. As soon as they see that insects are nibbling on their leaves, certain plants send out chemical messages. These volatile molecules float to other plants of the same species, where they cause them to put up a fight by making bitter chemicals, toughening their tissues, or even drawing in insect predators. Cays communicate with one another in this way when danger is near. Herbivores even stop eating some plants because of the drastic changes in flavor they bring to their leaves. These warnings are imperceptible to the human senses. They may be borne on the wind as subtle scents that go unnoticed. Cries of panic, though, are heard amid the still battlefields of woodlands and fields, like unseen messages carried by the wind. It turns out that plants do not sit on their hands and let their destiny unfold. They communicate by a language written in chemical and fragrance, and they are actively involved in the survival process. A Venus flytrap can keep track of its victim's motions. Among the most recognizable predators in the natural world is the Venus flytrap, a plant that, when attacked by unwary insects, snaps shut. However, it does not squander resources on unfounded warnings. Tiny trigger hairs are contained within each trap. No amount of pressure is felt. However, after around 20 seconds, the trap will close, ensnaring the victim inside. The plant is truly keeping track. After it closes, the plant releases digestive enzymes that break down the insect into nutrients whenever it is touched again. Because of this counting system, the plant will only expend energy in response to a genuine meal. Something devoid of neurons and a brain can exhibit such complex behavior. When you see a Venus flytrap in operation, it's like witnessing green intelligence. The hunter lies in wait, silently precise in its response timing, transforming stillness into strategy in the most unexpected way. There are plants that can recall their own histories. When we think of memory, we usually picture animals. However, it seems that some plants can recall things too. Scientists conducted studies by gently dropping the Mimosa pudica plant, which is known to fold its leaves in response to touch. Initially, the leaves flocked together in a protective manner. However, the plant eventually ceased responding, as if it had figured out that the stimulation wasn't harmful after all. Even after all this time had passed, The plant could still recall the harmless droplets. It only responded to other dangers. This memory is not based on neurons, but on metabolic alterations in cells that change their response to stimuli. It proves that non-living things can remember things and change their actions based on those memories. Even though they're firmly planted, plants aren't mindless. They take note of events in their own unique ways, absorbing knowledge from their environment. One day is enough time for bamboo to grow nearly a meter. Bamboo grows at an almost miraculous rate, making it one of the quickest plants on Earth. Certain species can, under perfect circumstances, expand nearly a meter in just one day. So rapidly that watchful onlookers claim to see it ascending. Its segmented, hollow stems efficiently channel water and nutrients upward, enabling it to develop at an explosive rate. People have used bamboo for a variety of purposes for hundreds of years, including building homes, making tools, and even making music. However, in many cultures, its swiftness is also seen as a sign of strength and rebirth. Bamboo can regrow after harvest in just one season, whereas forests of trees need decades to reach maturity. It serves as a structural element and a living symbol in its native habitats. Power through endurance, agility by adaptability, and swiftness by careful planning. The amazing and profoundly poetic development of bamboo exemplifies the capacity of nature to thrive with astonishing rapidity. The biggest flower in the world is produced by the Titan arum. The Sumatran rainforest is home to a shrub whose blossom has surprised botanists and travelers. Titan arum, also known as quartz flower. Rarely does it bloom, but when it does, a single flower stalk can soar to a height of more than 3 meters, like a spire. As it opens, the blossom reveals a scarlet inside and lets out a smell like spoiled flesh. As they scurry around aimlessly in quest of food, the stinky smell entices pollinating beetles and flies. Among the biggest and most peculiar blossoms in nature, for the little time it opens, the flower transforms into a grotesquerie and a sight to behold. Wondered onlookers swarm botanical gardens in droves whenever Titan arums are in bloom. Titan arums embody the ebb and flow of existence in their enormous but transient bloom. Swift, daring, and memorable. Orchids can fool insects by mimicking the way a female plant feels. Orchids are experts at playing tricks. Insects can attract mates by changing their appearance and smell to resemble that of a female. Their petals transform into bug bodies, and chemicals secreted by their surfaces emit scents similar to pheromones. While trying to mate with the flower, male insects are tricked into brushing up against the pollen as they are fooled by the mimic. Unknowingly finishing the plant's reproductive cycle, they carry the pollen with them as they go on to the next orchid. This tactic verges on deceit, a meticulously constructed biological illusion. If you ask an insect, the orchid is a beautiful flower, a temporary guarantee that is both alluring and untrue. The exquisite blossoms showcase evolution's crafty survival strategies, which rely on artifice, persuasion, and the subtle art of seduction rather than force. Pollinators are attracted to the corpse flower by the stench of decaying flesh. Standing next to a blooming corpse flower is one of the most startling nature encounters. This enormous bloom is native to the Sumatran rainforests and has a stench so pungent that it can be smelled from hundreds of meters away. To the human nose, it resembles the putrid odor of decaying flesh. However, for flies that prey on dead animals, it serves as an enticing temptation. They transport pollen from bloom to bloom as they make their way through the flower's hollow interior. This approach is effective. The plant assures its survival by acting as if it were dying. During its short flowering period, the corpse flower attracts large audiences who are both captivated by its eerie beauty and repulsed by its stench. A lesson is contained in its macabre allure. Revulsion, for example, can be channeled into a reproductive strategy. There are seeds that can remain dormant for a very long time. Plants store their memories in seeds. They patiently wait for the ideal circumstances to awaken, encased in protective shells, while carrying the blueprint of future life. It may take millennia, not years, for certain seeds to mature. After more than 30,000 years in the frozen tundra, scientists in Siberia successfully grew a flowering plant from a seed. A date palm seed that had been dormant for 2,000 years was revived in the Judean desert, and new leaves began to emerge, reaching for the light of the modern sun. The capacity to virtually completely shut down metabolism is the source of this endurance, protecting fragile tissues from the gradual ravages of time. Buried in the dirt or hidden away in old artifacts, seeds may look lifeless, yet they actually contain a spark of potential that might be nurtured for centuries. By gently grasping a seed, one may sense the enduring power of nature as it lulls the woods of tomorrow to a peaceful slumber. From salt water, mangrove trees may extract salt. Roots entangled like knotted webs characterize mangrove forests that occur along tropical coastlines where the ground meets the water. In the saline brackish seas where most vegetation dies off, these trees flourish. Adaptations that mangroves have developed to stay alive are very remarkable. At the root level, some species remove salt from the water and bring up only fresh water. In contrast, several species secrete a crusty white residue after excreting salt through leaf glands. Not only do they help keep trees stable, but they also serve as habitats for many other kinds of animals, including fish, crabs, and many more. Mangroves provide a living barrier between land and sea, preventing erosion and storm damage to coastlines. Protectors of the coast, they flourish in environments with both salt and fresh water. There is an engineer and a protector in every tree. This is more evidence that adaptation and subtle resilience are more common than outright resistance when it comes to surviving in hostile circumstances. Underground seedlings allow some grasses to withstand wildfires. At horrifying speeds, wildfires consume entire landscapes, turning farms and woods into ash. However, it is not uncommon for life, particularly in the grasses, to emerge once the smoke has cleared. Some grasses, in contrast to many plants, store their life force underground in robust organs known as rhizomes or bulbs, which allow them to survive leaf burns. These concealed components are always ready to sprout new, verdant blades, even when the surface is scorched. Tender sprouts, feeding grazers, and regenerating ecosystems can turn burned soil back into a glowing surface in a matter of weeks. Periodic fires are essential for the renewal of many grasslands because they remove dead vegetation and fertilize the soil with ash. Part of their reincarnation cycle includes fire, which seems destructive. The resilience on display in a prairie's recovery from a fire is a powerful reminder that death and rebirth are frequently interdependent cycles in nature. The construction of coral reefs is a feat of microscopic organisms, yet these ecosystems rely on them. Expanding underwater metropolises teeming with colorful fish, turtles, and other marine life are what come to mind when one thinks about coral reefs. However, the tiniest marine organisms are the ones responsible for constructing reefs. Polyps of coral, little creatures related to jellyfish. The rigid skeletons that accumulate into reefs over thousands of years are formed when each polyp secretes calcium carbonate. Each one is delicate and little, but when joined they form structures that can be seen from space. A quarter of the marine life on Earth finds refuge in these reefs, which they use for shelter, food, and reproduction. As living barriers, they shield shorelines from storms and waves as well. Tropical waters would be devoid of life if corals didn't exist. The delicate yet essential kingdoms of beauty and biodiversity are built by their silent effort. Floating among them is like swimming through a living cathedral, constructed by innumerable tiny creatures cooperating over many centuries. The clownfish and the stinging anemones are inseparable. Clownfish, a colorful resident of coral reefs, make their home in the tentacles of sea anemones, an area that is inhospitable to the vast majority of marine life. Clownfish are protected by a unique mucus coating, while anemones possess stinging cells that paralyze fish upon contact. Thanks to their special adaptation, they can hide in the anemone's protective hug without being hurt by the venom. Clamfish, in exchange, offer their hosts a number of advantages. They aid the anemone's breathing by warding off predators, cleaning up detritus, and stirring the water. The bond between the two is so strong that the fish hardly ever leave their home. It is easy to understand why they have captivated humans as you watch them dart among the swaying tentacles, which are a vibrant orange color, and the arms, which are either white or purple. In this interaction, there is a fine line between risk and safety, the ability for two species to rely on each other and stay alive. Other fish line up at cleaner fish run stations. Certain fish species on reefs have an unanticipated function. Barbers and doctors to their neighbors. Wrasses and other cleaner fish create cleaning stations where predators and larger fish can congregate without fear. The larger fish sit tight and wait for their turn to be cleaned while the cleaners swoop over them, nibbling at parasites, dead skin, and debris. The parrotfish, eel, and grouper all offer their surrender. Occasionally, they will open their mouths wide to allow cleaners to swim inside and clean their gills. Both parties gain from this conduct. Both the cleaners and their clients benefit from the elimination of bugs. Species that could be adversaries living side by side in harmony at a reef cleaning station is like witnessing a spa or market. That neutralism may thrive even in the cutthroat environment of nature is seen here. Those rare times when working together in harmony is more important than fighting for one's life. There are sharks that swim non-stop. As a matter of life and death, swimming is essential for numerous shark species. Suffocation would ensue in its absence. A few shark species depend on their continual forward movement to propel oxygen-rich water through their gills, in contrast to fish species that can do this while at rest. Night and day, these obligatory ram ventilators, like macro and great white sharks, are on the move. While swimming, they put certain regions of their brain to sleep, a transitional state between wakefulness and slumber. Because they are always traveling, they exude an air of mystery. They are never really still. Observing footage of these sharks gracefully swimming around in the ocean, their rhythm is foreign and unsettling, designed to roam aimlessly rather than rest. To them, the ocean serves as both a pathway and a bed, an environment where continuous motion is the sole means of survival. The moon and stars help sea turtles locate the water. Newborn sea turtles attempt a desperate crawl toward the ocean on warm beaches after digging themselves free from their eggs. Following their gut, they swim toward the lightest source of illumination, which is typically the moon or stars reflecting off the water. Using this long-forgotten method of navigation, they have been able to guide their young to the great ocean for millions of years. Adult sea turtles make much longer journeys, often traversing whole oceans, before making their way back to the beaches from where they emerged. Although they use both magnetic fields and astronomical signals, the exact mechanism by which they attain such accuracy is still somewhat of a mystery. Imagining a being who uses the twinkle of stars as a navigational aid is like catching a peak of a navigational system that predates both maps and compasses, one that relies on the sky itself. Their adventures show us that a single light can illuminate a path through total darkness. It is safe for penguins to sip salt water. Fresh water is typically in short supply in the penguins' home oceans. Even so, they seem to be doing just fine, swimming and diving for hours on end. The salt-filtering glands located above their eyelids are their secret weapon. These glands secrete concentrated droplets of salt via drooling beaks or tiny sprays of saliva after these animals consume salt water or briny fish. Because of this change, penguins can stay alive in tropical regions where people would rapidly get dehydrated. They are no longer reliant on rivers or rain for their survival. They are free to enjoy the ocean to the fullest. As a delicate physiological marvel, seeing a penguin shake its head and release a thin mist of salt water is a sight to behold. A design that is fine-tuned for ice and salt water is concealed within their tuxedoed bodies. A migratory bird that transformed the ocean into a never-ending source of water. While in flight, some birds doze off. On the high seas, far from land, where it is hard to rest. Flying is a common way for certain birds to get some shut-eye. One example is the great frigate bird, which flies for weeks on warm currents without ever touching down. Scientists have found that when these birds fly, they temporarily deactivate half of their brains so that one side may rest and the other can keep an eye on the road. Even though they only last a few seconds, the bird is able to endure long flights without ever hitting the ground thanks to these micronaps. Adapting to dream while moving, to relax without stopping, is really mind-blowing. Envision yourself suspended in mid-dream, eyes partially closed, being swept by unseen breezes. When it comes to birds that live on the brink of endurance, sleep is just as adaptable and inventive as flying. Gliding for hours without flapping, albatrosses are able to glide. Throughout their lives, albatrosses soar over enormous oceans, demonstrating their mastery of the wind. Their wingspan of up to 3.5 meters makes them ideal for a flying maneuver known as dynamic soaring. They harness the force of the unseen airwaves by deftly angling into the wind currents, which cause them to rise and fall in enormous arcs. They are able to glide for long periods of time, even days, without flapping their wings. Albatrosses are able to effortlessly travel tens of thousands of kilometers annually as a result of this gift. Only during mating season do they land on land, and while flying they sleep and sip rainwater collected in their beaks. Observing an albatross soaring aimlessly over the water is like being a fly in a wind tunnel. The bird seems to be one with the air, gliding with the wind as if the sky were a continuous highway. The heart rate of a hummingbird is more than 1,000 beats per minute. The dazzling hummingbird is one of nature's most remarkable athletes, despite its diminutive size. They can hover in one spot and dart in any direction because their wings move at a rate that the eye can't keep up with. Their hearts beat at incredible speeds, more than 1,000 beats per minute, to power his feet as they soar through the air. Their metabolism is so fast that they visit hundreds of blooms every day in search of nectar, which they must consume nearly continuously. Torpor is their energy-saving mode at night when they drastically reduce their heart rates, basically going into a mini hibernation to save energy. Extremes in nature are demonstrated by hummingbirds. Microbes that can fly non-stop across the Gulf of Mexico while weighing less than a cent are incredibly powerful. A rhythm as rapid and raging as the fires of life itself beats in their little jewel-like bodies. Exquisite courtship dances are performed by certain birds. Among the many animal courtship rituals, certain birds' displays of affection reach a high level of artistic expression. As an example, the intricate dances performed by birds of paradise are truly mesmerizing. Following the clearing of display areas on the forest floor, the males hop, swing, and unfurl feathers to create mesmerizing forms of light and color. When certain species stretch their wings and tails in symmetrical patterns, it's as if their bodies were living kaleidoscopes. The accuracy and originality of these displays are important factors in the mating process. Thus, the female birds observe them intently. In another part of the world, grebes run across the water in perfect harmony, dancing gracefully with one another. There is more to these rites than meets the eye. These are actions that have been refined through time. With every step, she exudes charm and energy. Such performances are like seeing a staged courtship. Grace, rhythm, and beauty, the essence of survival. A lyrebird's call can sound like a chainsaw or a vehicle alarm. The lyrebird is a resident of Australia's deepest woodlands, unparalleled in his ability to mimic. Its very stunning tail feathers resemble a lyre. The voice, nevertheless, is its real asset. The ability to mimic nearly any sound is possessed by lyrebirds. The soundscape is filled with a myriad of sounds, including birdsong, wind in the trees, camera shutters, chainsaws, and automobile alarms. To woo females, men incorporate these mimics into complex tunes that blend real and synthetic sounds in an eerie symphony. When you're in the middle of a forest and you hear a lyrebird call, it's as if the environment is playing tricks on you. Their impersonation is so lifelike that it may trick anyone. Nature bestowed her musical and impressionistic skills on the lyrebird, allowing it to reenact the contemporary world via its evocative primal song. The Arctic Circle rotates around the Earth once a year. There is no traveler like the Arctic tern. It travels from its Arctic breeding sites to Antarctica and back again every year, a journey of over 70,000 kilometers in total. Because of this, the tern gets to enjoy 2 summers per year as it chases the sun all around the world. A single bird has the potential to fly the distance of 3 circumnavigations of the moon in its lifespan. Despite its fragile look, the tern is able to withstand oceans, storms, and seemingly limitless skies thanks to reflexes that scientists are only now starting to decipher. Movement characterizes this being, as does the never-ending cycle of distance and light. Migratory behavior is more than simply a means of subsistence. It is a cosmic dance, as any observer of such a small bird will tell you. A recorded existence that appears on Earth's physical map. Spiders can soar through the air with the help of silk parachutes. The necessity to disperse far from their congested origin is a common challenge for newborn spiders. They came up with a brilliant answer. They ascend to a lofty vantage point, lift their bodies, and let fly silken threads that flutter in the breeze. They float through fields, forests, and even oceans like living parachutes thanks to their inflating tendency. Among the clouds, spiders have been discovered thousands of meters up in the air. Still others have stowed away on invisible air currents and landed aboard ships far from land. Behold the incredible grace of wingless flight as you observe a spider delicately ascending into the air, supported only by threads of gossamer. As a result, we are reminded that the sky is actually teeming with tiny, invisible beings who are being softly taken into the unknown on threads of silk. The silk spun by orb weaver spiders is more durable than steel. Orb weaver spiders, with their symmetrical webs that shimmer in the morning dew, are among the most stunning engineers in the animal realm. One of the most extraordinary materials found in nature is the silk that they manufacture. Compared to steel, it is lighter than cotton, but stronger per gram. As a result of its elasticity, it can withstand pressures that would break other fibers. Spiders use a variety of silks, each with its own unique properties, to spin a web. Silk for covering and protecting, strong radial threads for capturing prey, and sticky spirals for adhering to surfaces. Spiders that spin orb weaver webs are incredibly delicate, yet they are capable of capturing insects that are several times larger than themselves. The intricacy of spider silk has long eluded human attempts to imitate it, despite the many potential medical, engineering, and textile applications. Every night, the spider manages to do something that even our most sophisticated technology has not mastered: weave its web with precision and grace. Underground, trapdoor spiders construct dwellings with hinges. Trapdoor spiders build their homes in the still earth, under the debris of leaves and grass. Their silk-lined burrows are the basis for their stealthy entrances, which they construct out of soil and plant debris and fasten with spider silk. The spider remains still within, listening for the entrance's tremors. The door flings open as the spider pounces on its unsuspecting prey, whom it then takes back inside. There is no sign of the ambush because the door swings shut once more. These clever dwellings serve as both a shelter from the elements and a vantage point from which the spiders may hunt. In contrast to the delicate webs spun by orb weavers, the secretive structures woven by trapdoor spiders are strongholds of patience. To walk right by such a tunnel would be to miss the hidden drama waiting for you below, a realm where unexpected turns, shadows, and hinges abound. Zombies can be conjured by certain wasps. Parasitic wasps, which trick other animals into becoming their unwilling hosts, are one of nature's most disturbing methods. To lay their eggs, several species use cockroaches or caterpillars as vehicles. After hatching, larvae feed on their hosts while secreting hormones that change their behavior. A single wasp uses a cockroach as a pawn in a puppet show before leading it to its nest, where it serves as a stepping stone for the developing offspring. Another one forces a caterpillar to risk its life to protect a wasp pupa. Even the minds of prey can be shaped by evolution, as shown by these seemingly science fiction activities. Instead of existing in complete life or death, the victim becomes a tool for someone else to stay alive. Considering such tactics is to catch a glimpse of the sly brilliance in nature. Revisions that are just as effective as unsettling. Honeybees use dances as a means of communicating their whereabouts. Instead of using words, honeybees communicate within the bustling hive through dance. A forager will return to a patch of abundant flowers and execute the waggle dance, a pattern of loops that indicates the direction and distance of the food in relation to the sun. As a result of their keen observation and accurate interpretation of the actions, other bees quickly swarm to the flowers that were mentioned. Through this network of communication, beehives are able to pool the intelligence of thousands of individuals to make the most efficient use of available resources. In addition to being quite accurate, the waggle dance may change to follow the path of the sun. Observing a community together by motion and vibration is like being a spectator at a beehive as its sisters spin in time with the rhythm, a language that predates even the flowers. Their dances embody the essence of beauty and survival, an evolutionary dance that each beehive follows. Tadpoles are carried by some frogs. Some frogs in the tropical woods of South and Central America adopt a gentle protective posture. For instance, the male strawberry poison dart frog keeps an eye on the newly hatched tadpoles. From the forest bottom, he ascends huge plants and trees, delicately carrying each one on his back. It is common practice to place each tadpole into its own little water container, such as a bromeliad pocket or the hollow of a leaf. The mother then makes frequent visits to provide them with unfertilized eggs, an altruistic sacrifice that allows them to continue growing. The degree of parental care displayed by these rituals is exceptional for amphibians. These amphibians take precautions to guarantee a secure environment for their young rather than relying on chance. An intimate and selfless aspect of survival can be observed when a frog delicately carries a wriggling tadpole through the forest. The Suriname toad is able to give birth by means of skin perforations. The Suriname toad is one of the most peculiar birth stories found in nature. During mating, the male presses fertilized eggs into the soft, spongy back of the female. The next step is for the skin to develop around the eggs, enclosing them in chambers that resemble honeycomb. They grow up in the protective environment of their mother's skin. After a few weeks, little toads that are completely grown come bursting out of her back like live pearls extracted from flesh pockets. Even though it's disturbing to behold, this strategy helps keep young alive by shielding them from danger. Life creates tactics as varied as our imaginations, and this is a stark reminder of that. The Suriname toad's unique motherhood involves repurposing its skin into a nursery and then back into a protective shell. What we find strange is actually just their way of life. Their ancient heritage is etched with an astonishing adaptability. The bodies of glass frogs are see-through. Little frogs squat on tender verdant leaves in the cloud forests of South and Central America. You find something remarkable when you examine it thoroughly. Their muscles and skin are see-through. The entire abdomen of several grass frog species is transparent, allowing one to observe the hatching eggs, winding intestines, and beating heart. Researchers think they may be able to blend in with the dappled light streaming through the leaves and evade predators thanks to their transparency. Their bodies blend virtually completely into the verdant backdrop as they cling to the undersides of plants. Their ethereal grace is as if they were portals into the human body itself. Observing a glass frog is like staring into the face of a vulnerable being. Its organs are exposed and beating, yet it is entirely concealed by a thin layer of living glass. Vermilion splotches are a feature of several reptiles. The North American desert is home to the horned lizard, an unusually defensive reptile with sharp spines. When it feels threatened by predators like coyotes, it has the ability to launch blood jets up to several feet from its eyes. Chemicals are added to the blood so that it tastes bad to the assailants, which makes them stop pursuing. Nobody uses this defense carelessly. The lizard has to force blood into its sinuses until they burst, which will briefly throw it off its sense of direction. Still, it accomplishes its goal of transforming a tiny, sluggish reptile into a prey item. One of the most peculiar survival techniques in the animal realm is the horned lizard's capacity to squirt blood, which it uses in conjunction with its spiky armor and camouflage. This serves as a reminder that the tactics employed by nature are often straightforward, yet highly successful. Into the arid sands came a shocking and inventive spectacle. Water is no match for the basilisk lizard's speed. Central American basilisk lizards are known as the Jesus Christ lizards because of an apparently supernatural ability they possess. It glides over the water's surface. It slaps the water forcefully enough to create air pockets with its muscular hind legs, fringed with specialized scales. It avoids drowning by swimming swiftly, skimming the surface of the water for a few meters before plunging in headfirst. While larger basilisks may dart across the water's surface to evade predators, smaller juveniles can run farther than their heavier adult counterparts. Seeing one dash over a brook makes one feel as if gravity had momentarily let go of their disbelief and let them fall into awe. It is not magic that the basilisk uses, but rather the laws of physics that it has evolved to use. The glistening light of a river in the rainforest, though, makes it seem like something out of a fairy tale. Gliding is a skill possessed by certain snakes. Some snakes perform the unthinkable in the dense woods of Southeast Asia. They soar across the air. To regulate their glide, paradise tree snakes flatten their bodies and jump off trees, undulating in the air. They create lift as they move by reshaping their ribs to act like living parachutes. They can land safely after a single leap of more than 20 meters, despite the lack of wings. Gliding past one of these serpents is like witnessing contradiction personified. Something we normally picture as rooted to the earth actually becomes a living ribbon swishing through the sky. Astoundingly graceful for something so implausible, scientists study their flying to understand aerodynamics. Snakes like these show that flying isn't just for birds and bats. Snakes aren't the only ones who soar through the rainforest canopy. The bites of Komodo dragons are poisonous. As the largest lizard on the planet, the Komodo dragon can reach a weight of 70 kilograms and a length of more than 3 meters. For a long time, researchers thought its strength came from the germs in its saliva and the keen teeth it had. Yet, another secret, poison, has been uncovered through investigation. Toxins are released into their victims by the venom glands that inhabit Komodo dragons. Inducing shock, these poisons dilute the blood, reduce blood pressure, and block coagulation. This poison, along with the sharp teeth of the dragon, makes its assaults extremely lethal. Komodo dragons hunt massive animals like water buffalo and deer by ambushing them with patience and stealth. Even if the animal manages to get away from the bite, it usually dies within a few hours. Afterwards, the dragon will feast by following its scent trail. It is easy to perceive echoes of prehistoric predators in the slow, deliberate gait of these enormous reptiles. An artifact from a simpler time has been preserved by evolution in the Komodo dragon. One way crocodiles can go for days without eating is by slowing their heart rate. Crocodiles are extremely resilient creatures. They are able to go weeks, if not months, without eating because their metabolisms are so much slower than ours. Their extraordinary mastery of their emotions is a key. Crocodiles can conserve energy and oxygen by slowing their heartbeat to a few beats per minute while they lie immobile in water or muck. They may wait for the ideal moment to attack, ambushing their prey with an uncanny sense of patience. When food is scarce, it allows them to go longer periods without eating, giving them an advantage over other predators. After more than 200 million years of evolution, a crocodile's body is essentially a living fossil. Their languid, rhythmic hearts reverberate with old cadence, serving as a reminder that being alive isn't always about being fast or active, but rather about being quiet, efficient, and patient. An almost eternal power resides in their quiet. In order to communicate, certain fish use electricity. Some fish have developed an electrical language to communicate in dark, cloudy seas, where vision is impaired. Subtle electric fields encircle the bodies of electric fish like knifefish and elephant nosefish. Their ability to sense objects, traverse in darkness, and communicate is enhanced by altering these signals. The electromagnetic patterns that fish use to identify potential partners and predators are distinct from one another. They fill the water with their silent chatter as they exchange pulses, waves, or bursts like coded signals. Electricity is a civilizing tool in our view. This sensation is as second nature to these fish as sight or hearing. Their experiences show how diverse our senses are and how strange and familiar other perceptions can be. A realm of existence unseen by humans can be glimpsed if one can envision water filled with imperceptible electric buzz. Electric eels have the potential to stun horses with their powerful shocks. Although they go by that moniker, electric eels are actually knife fish and not real eels. Their capacity to produce electric discharges as strong as 600 volts has made them famous. This was enough to stun a horse in the past, and even a human. Their electrical abilities serve them well in both hunting and self-defense. The eel can consume its victim alive after a quick shock paralyzes it. In order to navigate and perceive their surroundings in dark waters, they can also generate weaker pulses. They have specialized cells called electrolytes, arranged like capacitors, all over their body, making them basically live batteries. These cells release an electric shock of tremendous power all at once when activated. The native inhabitants of the Amazon region have a mixed relationship with electric eels. Experiencing one is like being struck by lightning, the unbridled, wild force of biology. Fish may be made to glow by using bioluminescent microorganisms. As dusk falls over the sea, light takes on dual purposes, as a weapon and a shield. Though they don't actually emit light, many fish in the deep ocean harbor bioluminescent bacterial colonies in organs that are specifically designed to do so. Under the water, these microbes produce a constant living light that serves as a lantern. To avoid being seen by predators below, some fish employ the glow to blend in with the dim light coming from above. For some, it's a fishing rod that brings game straight to their jaws. There is mutual benefit to both parties. Bacteria produce light, and fish supply shelter and food. In order to make patterns in the dark, some fish, like the flashlight fish, have glowing patches behind their eyes that they can turn on and off. The idea of animals propelled by microbial communities seems bizarre to us. This kind of collaboration is widespread in the deep, though. There are methods for light to shine in the dark. Color changes are a means of communication for some squid. When it comes to marine life, squid are among the most showy. Colors and iridescence come to life on their skin. Chromatophores, microscopic sacs of color that elongate and shorten at the speed of light, lie underneath their surface. With them, squid may change their body color from white to a deep red in the blink of an eye. Many species, according to scientists, employ this ability for communication as well as camouflage. As a courtship, aggressiveness, or collaboration signal, squid groups frequently synchronize their colors, pulsating stripes or spots in unison. Picture swarms of squid swimming around like a living light show. Discussions conducted through bursts of color that we are unable to completely understand. From a human perspective, these displays appear paler, resembling underwater neon signs. For squid, though, it's all just language, a constant, ever-changing pattern of living skin that serves as a wordless discourse. The vampire squid inhabits low-oxygen environments. A delicate, deep-sea survivalist, the vampire squid belies its ominous moniker. The oxygen minimum zone is one of the ocean's most hostile habitats, where oxygen levels are dangerously low and most marine life dies off. With its gelatinous skin and a web-like shroud that connects its arms, the vampire squid conserves energy as it wanders slowly. Its hunting behavior is distinct from that of its cousins. Instead, it rolls organic particles in the form of marine snow, drifts of organic matter with sticky filaments, into meatballs. Its name is derived from the spooky aspect and dark color it has. However, rather than acting predatorily, it gathers food gently. It has carved itself a place in seemingly uninhabitable seas, acting as a spectral remnant of long-gone cephalopods. The vampire squid demonstrates that brute force and aggression aren't necessarily necessary for survival. It may necessitate learning to be frugal, efficient, and patient at times. The enormous squid's eyes are as big as dinner plates. Huge squids, so rare that only a small number have ever been caught, lurk in the shadows of Antarctica's oceans. A real leviathan of the ocean, it can reach lengths that are comparable to enormous squids, but even heavier. Its bewildering eyes are its most striking trait. Its largest known size is 30 centimeters, or about the same as a dinner plate. Its massive eyes can pick up on the tiniest hints of light in the dark, like bioluminescent prey or the shadow of a predator like a sperm whale. Seeing such an eye would be like staring into the vast depths of the ocean, which would be overwhelming. Even though we know very little about gigantic squids and their habits, we can deduce the vastness and darkness of their underwater habitat from the size of their eyes. Transparent heads are found on several deep-sea fish. A peculiar species known as a barrelfish floats aimlessly in the pitch-black depths of the ocean. Its eyes, which are illuminated by a subtle green light, are visible through the translucent dome of its head. The fish remains motionless as its eyes dart upward, studying the faint outlines of prey overhead. The ability to move the eyeballs forward allows them to follow approaching food if necessary. Thanks to its peculiar construction, the barely can survive in almost complete darkness with pinpoint accuracy, all the while preserving energy and remaining vigilant. Coelophores are gelatinous predators that rule the ocean, and this fish uses its see-through skull cover to protect its sensitive eyes from their stings. Seeing a little fish is like catching a peek of an extraterrestrial. The skull of this beast serves as a window rather than a barrier, using its mechanisms as a means of self-defense. As a reminder, the form itself is rewritten in the depths of life. The anglerfish hunts with the help of a glowing lure. The terrifying lantern and sharp teeth of the anglerfish are two of the most disturbing depictions of the deep sea that one can imagine. A fleshy stalk adorned with bioluminescent bacteria, resembling a living light bulb, protrudes from its head. This hook gleams in the dark depths of the abyss, luring inquisitive squid and fish. The anglerfish swallows food at nearly half its size when it snaps its jaws shut with lightning speed as they approach. Males occasionally fuse permanently to their bodies, becoming little more than appendages supplying sperm, while larger females hold these lures. It seems more like this strange way of living is fiction than reality, but that's just the way deep water survival is. The anglerfish has turned light, a symbol of hope in the dark, into a trap by weaponizing it. Crabs can accessorize themselves with real sponges. There are various sorts of underwater camouflage, but certain crabs really master it. Decorator crabs utilize their hooked bristles on the shell to affix fragments of sponge, coral, and even live anemones. Their forms are hidden by these ornaments, which blend them with the reef's backdrop. We have some strategic choices. Sponges can secrete toxins, while anemones sting potential predators for added defense. The anemone is able to move to different hunting grounds thanks to the crab. An embellished crab's movements are like witnessing the resurgence of a section of reef, a veritable walking garden. What appears to be whimsy is really a survival tactic, a smart partnership between the organism and its surroundings. Some crabs, caught in the never-ending battle between predators and prey, don't hide. They transform into living landscapes. Hermit crabs exchange shells by forming vacancy chains. A hermit crab's shell cannot be produced by its own body. They take snails' empty ones and use them. However, they'll need to upgrade to bigger houses when they get older. This frequently results in extraordinary group dynamics in nature. A large number of hermit crabs will congregate around a freshly formed shell to examine it thoroughly. They line up from smallest to largest, waiting for the crab in front of them to transfer into the new shell so they can take it if it's too big. Hundreds of crabs, maybe even thousands, can be involved in these vacancy networks, which entail the precise scheduling of house relocations. Collaboration makes sure that everyone wins, transforming the competition into a community affair. The fascinating and entertaining experience of watching crabs exchange shells is reminiscent of apartment residents trading. Observation of the ability of even the most basic organisms to deal with shortage by displaying signs of order and patience. Not all Shropshire sheep are colorblind. The amazing human eye contains 3 distinct kinds of color receptors that enable us to perceive the entire rainbow. A tiny marine predator known as a mantis shrimp can actually carry as many as 16 different kinds. This allows it to see things in ways we can't fathom, picking up on polarized and ultraviolet light that humans can't see. Hidden from human sight, the reef is probably a kaleidoscope of shapes, colors, and signals for the mantis shrimp. Both hunting and communication benefit from these abilities. It is hard to put oneself in a mantis shrimp's shoes because their shells emit signals that are visible only to one another. We don't understand this palette. They serve as a constant reminder that our perception is limited to a single version of reality and that there are many more. We will never be able to fully appreciate the ocean's myriad hues. When it strikes, the mantis shrimp does it with the force of a bullet. In addition to having extraordinary eyesight, mantis shrimps have one of the quickest strikes of any animal. Its club-like limbs are so fast that they cause cavitation bubbles, which are small holes that pop when exposed to intense heat or light. Crabs and snails can have their shells cracked and aquarium glass shattered by the force of the hit. The punch hits its target with the velocity of a bullet. An intricate network of spring-like mechanisms and shock-absorbing tissues allows the mantis shrimp to deliver these blows repeatedly without injuring its own limbs. One hunt is like witnessing the laws of physics in action, an explosively precise being that harnesses mechanics. Incredibly perceptive and incredibly powerful, mantis shrimp exude fierce intelligence despite their diminutive stature. Subtle but formidable, these coral reef gladiators lurk in plain sight. There are worms that, when submerged in water, provide a green light. As the sun sets and the sky grows dark, certain worms emit an ethereal green light that illuminates the ocean at dusk. Polyatos are delicate beings whose bioluminescent bodies glisten. If they feel threatened, they may let out luminous particles into the water, which they then use to make emerald fire streaks as they go. While scientists speculate that this light could entice partners or deceive predators, we find it utterly hypnotic. Light strands gliding through the water. The light from these worms is gentle, like a gentle breath in the night, in contrast to the ferocious lanterns of anglerfish and the abrupt bursts of squid. In spite of their diminutive size, these creatures have figured out how to make their survival an entertaining show. Their brief but unforgettable presence is written in light in the unending blackness of the ocean. Some people construct chimneys on the ocean floor using metal sulfides. The ocean floor is home to hydrothermal vents which blast mineral-rich hot water from fissures in the Earth's crust. Surrounding these vents are peculiar chimneys that were constructed by chemical processes rather than human hands. Several meters tall, ragged structures can be formed when hot water meets cold seawater, precipitating metals such as iron and copper. Black smokers are those that spew out plumes of water that are rich in minerals. Rather than being inert rock, these chimneys are the building blocks of whole ecosystems. In this chemically rich environment, tube worms, shrimp, and crabs congregate in dense colonies to feed on bacteria. Being in close proximity to one would be like looking at a mysterious, glowing metropolis that materializes out of the night. In a solar-blackened universe, these chimneys stand as living monuments to the peculiar chemistry that allows life to persist in the harshest environments on Earth. Hot springs can be a home for some creatures. Water in volcanic areas can get almost boiling when steam rises from the ground and hot springs bubble. Such extremes are fatal for the majority of life forms. And yet, thermophiles, a special group of organisms, do not just endure, but thrive. These acid pools are ideal for microbes and archaea. Their enzymes figured out how to work, while ours wouldn't. Some of these plants even impart their vibrant colors to the pools, making the water a kaleidoscope of green, orange, and yellow. It is not uncommon to find higher species, such as crustaceans and worms, tolerating temperatures that are hard to fathom. These creatures show us that the range of life is far larger than we imagined. Astounding resilience may be seen peering into a boiling spring and seeing life stirring. Nature creates new meanings of possibility in seemingly hostile environments, proving that our imaginations are not the only constraints on our ability to survive. Some live and flourish in acid lakes. Some earth lakes are so acidic that they might dissolve metal, and these locations appear completely inhospitable to any form of life. There are still bacteria here. Extremophiles that love acid flourish in environments with pH values around 0, such as the Dalol pools in Ethiopia or in abandoned mine drainage. They are able to sustain life despite inhabiting what appear to be chemically hostile surroundings, because their proteins and membranes are designed to withstand corrosion. The environment appears painted when some produce colors as vibrant as reds, oranges, and yellows. These creatures show us that life can persist in extreme environments, which may lead us to believe that there are living forms beyond Earth. Species that do well in acid lakes on Earth may be able to handle the extreme chemistry of other planets. Even in the face of seemingly insurmountable obstacles, these microscopic organisms demonstrate that life is resilient, creative, and unyielding. Miles underneath the surface of the Earth, bacteria reside. Miles of undiscovered habitat await us beneath the surface. Isolated from the outside world for millions of years, bacteria survive under tremendous pressure in these microscopic fissures and pores that are filled with water. Hydrogen gas, which is produced when water slowly reacts with rock, is a source of survival for some. Some people ingest trace amounts of sulfur compounds or methane. The life cycles of these bacteria are counted in millennia, not by humans, because they dwell at such depths and on such lengthy timescales. In places where sunlight has never reached, scientists have discovered thriving microbial populations while drilling into deep boreholes and mines. There might be more life forms in this subterranean biosphere than in all the seas put together. Down below, there is an unseen sphere of life that is silently pulsating. Our perspective on Earth is transformed. The planet is constantly humming beneath the surface, with an invisible yet undeniable life force. Sulfur and heat are the only things that some animals can eat. In the shadow of seafloor hydrothermal vents, where hot water rushes up from the depths, bizarre life forms flourish in the absence of oxygen and sunshine. Chemosynthetic processes power the ecosystems of enormous tube worms, clams, and crabs, as opposed to photosynthesis. Chemical energy conversion. Symbiotic bacteria inhabiting tube worms generate energy from hydrogen sulfide, a chemical poisonous to most forms of life. Nutrients are supplied by these bacteria, which nourish their hosts internally. Those worms, with their meter-long bodies and blood-red plumes, look like some kind of extraterrestrial creature with its roots in the shadows. Their environment appears inhospitable, poisonous, and completely dark to us. The fact that life exists here in such abundance demonstrates that our planet is dependent on sources other than the sun. The fact that these sulfur-powered towns exist is proof that life is incredibly flexible. It finds energy wherever it can and can even turn poison into food. Life may exist under nearly any condition, as shown by extremophiles. Radiation, extreme temperatures, both hot and cold, pressure, both high and low, and acidic and alkaline pools and lakes. Life has been discovered in every previously thought to be inconceivable location. The extremophiles that call these places home test all of our biological presumptions. Some microbes can withstand radiation doses that are thousands of times higher than the human body's protective shielding. Others are able to withstand extreme drying out, losing almost all of their water content and then remaining dormant for decades until they are resurrected. The extremophile community as a whole demonstrates that the range of possible habitats is vast, not limited. Both our perception of Earth and our ideas of life on other planets are transformed by this realization. There must be life on Mars, Europa, or Titan if bacteria can survive in such hostile environments as acid, ice, and boiling vents. Life is not fragile but tenacious, extremophiles whisper, adding that it may be universal and waiting for the right conditions to emerge. Living dinosaurs, birds, are. Observing a hawk swooping low in the sky or a robin sitting on a fence is like looking at a living relic of the dinosaurs. Birds are not merely distant relatives of them. They are theropods, descended from velociraptors and other dinosaurs. Long before birds learned to fly, feathers served as insulation or ornamentation. They later developed to allow birds to glide and soar. The hollow bones and claws on bird skeletons are remnants of their reptilian predecessors. When we learn that birds are actually dinosaurs, our perspective on the past changes dramatically. The great ancestors of the monsters who had dominated Earth continued their reign by ascending to the heavens. A tale that began over 200 million years ago is being carried on with every chirp, flutter, and flock in flight. The giant prehistoric beasts can still walk on two legs. Upon waking, they sing from their perch in the air. After 200 million years, crocodiles still look much the same. As the dinosaurs gave way to birds, crocodiles stood the test of time. Since their relatives went extinct more than 200 million years ago, modern crocodiles seem very similar to them. Evolution had no need to change their anatomy because of how well adapted they are. With armored skin, powerful jaws, and stealthy ambush techniques. As the world's oceans splintered apart and new mammalian species emerged, crocodiles were there to see it all. Even so, they persist. Patience and efficiency were crucial to their survival. Worldwide, you can find them in rivers, marshes, and along coastlines. They can also decrease their metabolism and go for lengthy periods without eating. Witnessing a crocodile basking on a riverbank is like seeing a glimpse of ancient history brought to life in the here and now. You could say they are living fossils. Help us remember that there are instances when timeless perfection, rather than continual change, is the best evolutionary approach. Not all fish have gills. Some also have lungs. The gills are the sole respiratory organs of the majority of fish species. However, there are creatures that can go between worlds via their gills and lungs. For instance, when ponds dry up, lungfish use their primitive lungs to gulp oxygen at the surface. They wait for the rains to come back by burrowing into the mud in Africa and South America when it's dry. These adaptations to breathe via both nostrils are evolutionary artifacts that point to a time when animals adapted to life on land, some 300,000 years ago. These animals show us that there is a gradient of adaptability rather than a hard and fast boundary between marine and terrestrial life. As we see a fish come to the surface for air, we catch a glimpse of our own roots. Because these fish were the progenitors of the amphibians, reptiles, and mammals that we know today, the lungs serve a purpose beyond mere subsistence. They provide glimpses into our ancient history. Mammals that walked on land gave way to whales. Though it's hard to fathom now, the biggest marine creatures actually trod the land at one point. The Pachycetus was a wolf-like predator that roamed the seas some 50 million years ago. Its offspring eventually learned to thrive in aquatic environments. Their tails sprouted formidable flukes, their nostrils moved to the crowns of their heads, and their arms expanded into paddles. Early whale fossils, such as those of Ambulocetus, the walking whale, demonstrate that these creatures were at ease both on land and in rivers. Over time, these animals abandoned land altogether, evolving into modern whales that live entirely in water. Whales are more than simply massive aquatic creatures. They are also mammals whose ancestors have made the long evolutionary trek back to the water. They remind us that even giants were nomads at one point in time by their migrations and songs, which harken back to a bygone era. Historically, horses' progenitors were no larger than toy dogs. These days, horses are strong, powerful creatures that can gallop across plains at high speeds. But their forefathers had a distinctive appearance. A diminutive animal known as the Eohippus, or dawn horse, prowled the woods of long-gone times 55 million years ago. It grazed on leaves instead of grasses and was as small as a fox terrier, with several toes instead of hooves. Horses became bigger. Their toes became hooves for speed, and they started eating rough grasses when the weather changed and forests became wide plains. Anthropomorphic changes in horse anatomy over millions of years illustrate how organisms adapt to new habitats. It is easy to lose sight of the fact that every horse's gait brings with it a long history of family history when we watch them gallop. The blue whale, the largest mammal in Earth's history, has come a long way from its humble beginnings as a little woodland dweller to its current status as a rumbling grazer. The blue whale is the biggest animal that has ever lived on Earth. It dwarfs all extinct dinosaurs. At 30 meters or more in length and 200 tons in weight, it dwarfs any previous animals. Despite this behemoth preys on marine organisms as little as shrimp. Krill are swallowed by the millions at once. They are little and shrimp-like. The blue whale is a majestic and surprisingly graceful animal, with a heart the size of a tiny car and a tongue heavier than an elephant. Its movements through the water are both breathtaking and delicate. Its low-frequency sounds may transport melodies over seas and hundreds of kilometers. Living side by side with blue whales is a living testimony to the incomprehensible marvels that this planet still holds. Living symbols of the enormity and force of life, and living proof of how enormous biology may grow. Even after hundreds of millions of years, certain bug species have maintained virtually no alteration. Some insect lineages have persisted almost unmodified since the dinosaur era, making them one of the most remarkable survivors of our planet. Fossil evidence shows that cockroaches, silverfish, and dragonflies looked very similar to their modern-day counterparts. More than 300 million years ago, dragonflies could glide across primitive woodlands with wingspans of more than 2 feet. Their design has survived, even though their size has shrunk, designed to be quick and nimble. Although they get a bad rap, cockroaches are evolutionary miracles because they have weathered many major extinctions with little to no change to their appearance. Insects like this have withstood the ultimate test of all time, and looking at them now is like looking at living fossils. We learn from their tenacity that evolution isn't necessarily about alterations. Consistency in an efficient design that doesn't require updating for 100 million years can be a recipe for success. After 5 major extinction events, life has bounced back. Tragedies have marred Earth's past. Major extinction events have occurred at least 5 times in Earth's history. Past extinction events include the Permian and the asteroid collision that put an end to the dinosaur age. After each calamity, ecosystems were emptied, making way for new life forms to emerge. Strange and wonderful new animals emerged as life bounced back from disaster. It is highly unlikely that either mammals or humans would have survived if these extinctions had not occurred. Life is incredibly resilient. Evolution keeps on, changing and remaking even when everything seems gone. The fragility and tenacity of existence are brought to light by mass extinctions. The living universe is more like a wildfire than a delicate flame. It may go out at times, but it always goes back up and continues to blaze into new eras. Antarctica is home to seeds that include genetic material from long-gone woodlands. Even though Antarctica is now a barren wasteland, it was formerly home to verdant coastal forests, ferns, and conifers millions of years ago. The frozen ground contains artifacts from this bygone era. Archaeological finds of seeds, spores, and other plant remnants have yielded DNA sequences. What previously flourished in a place now covered by ice is revealed by these artifacts. They illustrate the tremendous climatic changes that occurred throughout history, turning verdant woods into frozen wastelands. A seed is like a genetic memory of a bygone landscape, a fragment of a world long since vanished. Their DNA is a molecular record of Earth's living history, even though these seeds can't grow anymore. Not even in the most desolate of locations are the signs of life lost irretrievably. Murmurs from a time when the most frigid continent was covered in verdant flowers. Ancestral viral DNA is present in human bodies. Virus remnants from long ago lie dormant in human DNA. Evidence of diseases that afflicted our predecessors aeons ago. Endogenous retroviruses are a group of viral genes that constitute approximately 8% of the human genome. Most have gone into a latent state and can no longer transmit illness. But evolution has found new uses for a few. For instance, mammalian pregnancy is made possible by one viral gene that helps build the placenta. This means that long-gone viruses are more than just passing through our DNA. They contribute to our humanity. There are remnants of viral infections in every cell in our body. Serve as a reminder that our DNA is not perfect, but rather a mosaic of evolutionary events. Some of our very essence comes from the bones of our former foes. It would appear that life has a way of transforming even invasions into opportunities, incorporating hardship into the very essence of being. Atoms from innumerable creatures are present in every breath you take. When you breathe in, more carbon dioxide is exhaled than oxygen. Every particle in the air has been in the body of an infinite number of creatures before you. Your exhaled carbon might have originated from a leaf, a bird, or even a prehistoric reptile. The air you breathe may have once circulated through the veins of a long-gone whale or mammoth. Our own breath connects us to every single moment of life on Earth due to the infinite recycling of atoms. Every breath we take is a link in a continuous chain that dates back billions of years. Inhaling becomes more important than staying alive. As a result, it becomes one with nature and the spirits of long-gone animals and plants. As long as we continue to breathe, we will always be a part of Earth's history, holding a little bit of every life form within us. The fact that we share life with each breath serves as a constant reminder of this fact. The genetic code is identical for every living thing on Earth. Everywhere you look, there are organisms, from oak trees straining for the sun to microbes buried in ocean vents. Every living thing, from hummingbirds to people, follows the same molecular code. DNA, a sequence of only 4 nucleotides, is the building block of all life on Earth. Surprisingly, this code is applicable everywhere. The language used to construct a mushroom is the same as that used to construct a whale. All forms of life seem to have descended from a common progenitor, an idea that took root billions of years ago and has since taken on an infinite variety of shapes and sizes. Our common ancestry with other creatures such as insects, fish, and trees dispels any sense of alienation. A deep reality is exposed. All life on Earth is related, continually branching out from the same source. There is a unique fingerprint in every genome, from the smallest bacteria to our own. Existence is a universal poem. Composed of elements formed in long-gone stars, you are unique. Stars lived and died in spectacular explosions called supernovae long before Earth came into being. Elements denser than hydrogen and helium were created in their blazing centers. Elements, carbon, oxygen, iron, and calcium. The explosion of those stars dispersed these fundamental components throughout the galaxy. Planets, oceans, and sentient creatures were formed when they finally fused. Everything you take in, from the bone-building calcium to the blood-purifying iron and the oxygen you breathe, originated in stars that went out of existence aeons ago. This is to experience the paradox of infinity and diminution. In fact, you are an integral part of the universe, with a little bit of stardust in every one of your cells. You are the product of a cosmic dream in which the cosmos dissolved into individual atoms. Always keep in mind that there is more to the night sky than meets the eye. You are looking at your own long-lost relatives. Our tour of Earth's natural treasures has come to a peaceful end, my friend. Our paths have entwined as we have sailed through forests, oceans, deserts, and mountains, traversing both the hidden present and the distant past. Luminous worms, ancient creatures, and singing whales have all been our companions on our travels. The narrative of life unfolded before our eyes as it repeatedly reconfigured itself, adapted to new circumstances, and lasted. Feel free to close your eyes if they're getting heavy. As you focus on the constant pulse of your breath, let it mirror the rhythm of the waves lapping at a shore, the flutter of wings, or the flow of life itself. As you take a breath, you become one with every living being who has ever existed. A little thread in the enormous continuous tapestry of Earth's history. When you wake up, please like, subscribe, or comment if you have appreciated this experience. That way, we can keep making money off of this channel and bringing these peaceful tales of awe to people all across the globe. However, at this time, there is no additional action required of you. As a living being, you contribute to the rhythm of this planet and to the vast mystery that is still unfolding. Allow that idea to embrace you with the same tenderness as the ocean envelops its living beings and the planet embraces all life. Do not worry, for you are a vessel for the tales of the stars and the seas. Sleep peacefully and dream gently. Farewell for the evening.